So definite integrals we've approached by talking about in terms of areas of rectangles if we go up to an infinite number of rectangles. But I do want to introduce here a really important concept for us. Definite integrals can be used to find areas between a function and the x-axis, but they're not necessarily the exact same value as the area between a function and the x-axis. So I'm going to use the area of a circle here to illustrate this. So a circle is not a function, but I can split it into two separate functions. So I could say here that, let's call the top function f of x, whoops, sorry about that, f of x, and we'll say the bottom function is g of x. So if I wanted to know the integral from -2 to 2 of f of x with respect to x, what that's saying is I want to know what is this area between f of x and the x-axis. Well, that's a semicircle with a radius of 2, so it's going to be 1/2 of pi r squared, which is, to simplify, 2 pi. But then if I say, well, what if I find the definite integral from -2 to 2 of g of x with respect to x, which is saying, what about this part? And this is going to be a value that's related to the area, but it's not going to be exactly the same as the area. And the reason for this is definite integrals are allowed to be negative because we said the height of the function is based on f of x, and f could be a negative value. However, area is never negative. Area is always a positive value. But in calculus, definite integrals, because they're based off of taking a function value times delta x, are able to be negative. And the way we basically remember this is if my area is below the x-axis, it needs to have a negative value. So the region that the definite integral is looking at for g of x is below the x-axis, so I'd have a negative. And then that area would be the semicircle with a radius of 2, so -2 pi. So above the x-axis, definite integral and area between the function and the x-axis, completely the same. Below the x-axis, the area is always positive, but the definite integral would be negative. Now, if you keep that in mind, that means we can use areas to evaluate definite integrals. So for example, if I had the integral from 1 to 3 of 2x with respect to x, saying, okay, so I'm going from 1 to 3, well, the definite integral is going to be this area between the function and the x-axis. Well, you can see that as either a rectangle combined with a triangle, or I see it as a trapezoid. Area of a trapezoid is 1/2 its height, which is the distance between the parallel sides, so the height of 2, times the length of each base. So here the height was 2, this base is 2, and this base is 6. And so I get the definite integral is 8. Now, if you're going to be using areas to evaluate a definite integral, you do have to remember that if I go below the x-axis, even though the area is still positive, the definite integral will be negative. So if I look at the integral from -1 to +2 of -x, I actually have two different regions because the definite integral is always between the function and the x-axis. So one region, I'm above the x-axis, so it's going to be exactly the same as the area. I'm going to have a 1/2 times 1 times 1. But then I'm below the x-axis, so even though my area is a positive 1/2 times 2 times 2, when I want the negative of that, when I add it up for my definite integral. Now, a third alternative, or another alternative, because we're going to learn a lot of different ways of evaluating definite integrals, is our calculators can find definite integrals. Uh, so one thing to keep in mind, like derivatives, our calculator is estimating these. It gives us excellent estimates, but there are times in which the calculator says, hey, this is what we think the definite integral is, but there's a mistake. So we have to be aware of issues that the calculator tends to ignore. Different ways of doing this. You can hit the math button or the common math commands button, which is next to the 9 on the Tl-nspire CX. That brings up our common math commands. We want to choose the definite integral, that picture that does not have a T on it. The one with a T is if we were typing and it doesn't treat it like a math symbol. It just says, oh, you're typing something. You don't want me to do anything with it. So you want the picture of the definite integral without the T. It'll put in a blank definite integral. You fill it in, hit enter. It gives you the definite integral, or the estimate for the definite integral. You can also hit the menu button, go to the calculus menu, and choose numerical integral. And it'll put in a blank definite integral for you to fill in, hit enter, and get your estimate.